So in this video, we're still going to be using our z-table. We're just going to actually be using it in a little bit different way. So first, how this is going to be different is it says instead of being interested in finding the probability that we would see a certain value, instead we want to know what value produces a certain probability. That is, we want to find a value that cuts off a certain percentile. To understand that a little bit better, let's look at an example going back to looking at women's heights. Recall when we worked with women's heights, we had a mean of 65 inches and this standard deviation of 2.75 inches. So I'm still going to be working with those values. But for this example, it says we want to find, well, what height cuts off the bottom 10% of women's heights? How is this different? Well, let's try to do our best to draw a picture to understand what this problem is even asking us to do. So I know I have this bell-shaped curve because we were told that women's heights were normally distributed. I know it has a mean of 65 inches. I do also know the standard deviation, but for these types of problems, it's going to be a little bit harder to ballpark where our value is. So you're just going to see me put the mean on these pictures. What I do also know is that if I had everything to the left of 65, that would be the bottom 50%. So I want to find the bottom 10%. So I know that to have 10% is going to be somewhere over here. So I want this shaded area to be 10% or 0.01 in decimal form. And my goal now is to figure out, well, what height corresponds to that? So can you see how this picture is different than the ones we had previously? Previously, we knew the numbers along the bottom, and we were trying to find the shaded area. Now instead, I know the shaded area, and I'm trying to find the value at the bottom. So we will come back and finish this problem, but let's understand first how we're going to approach the problem. So we're going to go back and look at our z-score formula. So we have that z is y minus mu, or the mean, over sigma, our standard deviation. So to look at this formula, let's actually first understand what our goal is. Looking back up here, our goal is to find a height of a woman. Well, before, where did I plug in the height of a woman? Right, it was this value that I plugged in here. So that corresponds to our value of y in our formula. Or in a sense, our goal is now to actually determine what y is. So that means I'm not going to actually know y. Things I definitely already know, right? We already know the mean and the standard deviation. I have both of those values for my problem up here, right? So I know them. So what that actually means is there's going to be another value that I need to find, even though I might not know how to find it yet. I need to find z. And I can't find z in the same way I did previously because I would have to know y, and I don't know y. So somehow I'm going to figure out, well, how do I come up with z if it's not a calculation? So first, looking at the actual formula then of what we're going to be using. If our goal is y, I'm just going to take this same formula I have up here, and I'm just going to solve it for y instead. So we would find that our y is going to be z times the standard deviation plus the mean. And since I already know the mean and the standard deviation, once I find z, I'm pretty much just going to be doing the math here to get the answer. So as you can probably guess, finding the z is what we want to focus on as well. So at the top of the next page, I have some sort of steps again with how to calculate cutoff values instead. So we're going to go through this for our original example. So we want to graph the bell-shaped curve and put the mean on there. We already did that when I drew my black curve. Then I want to figure out how much shaded area is asked for and where it should go relative to the mean. I've done that already. We decided that 10% would have to be below 65 since this would be 50%. And so we shaded that. Now why did I shade left? Right, it's the bottom 10%. So we've really already done the first two steps in this process. Our next step says decide how much area is to the left of that value. Now first, let's talk about why left. Recall, I'm going to be using this table again. This table always looks to the left. I can't change that about this table. So I know I'm going to be looking to the left. So let's do that for our problem. So if I look at my question mark, how much is to the left of that question mark? Well, that's our 0.10. Now let's talk about what this 0.10 actually is. That 0.10 is actually a number on the inside of this table. So notice first that all of these values on the inside of the table have 4 decimal places. So when I actually write out what I'm going to be looking for, I'm going to go ahead and give that value 4 decimal places so that I know what I'm looking for. Let's also use some intuition here of what our answer should be. Right, I know my answer better be less than 65 inches when I'm done, or I've done something wrong. And before, you remember, if we fell below the mean, that meant that our z would be negative. The same thing is going to be true here. Our z needs to be negative that I'm working with to force me to be below the mean. So what we're going to do is we're going to take this value of 0.1000 and we're going to find the closest thing we can on the inside of this z-table. I already know my z-score should be negative, so I'm going to be on the negative page. The good news is you're not going to find the correct answer on the positive page. So what I like to do is go down this first column until I see a jump in the number I want. So I'm looking for 0.10. So I see right here between 0.09 and 0.11 is where 0.10 will fall somewhere between. And then I'm going to work over in these 2 rows until I find the closest thing to our 0.1000 that I can find. And here is the closest thing I found was 0.1003. So first I'm just going to write down what I found. So I wanted 0.1000, but I found 0.1003. Now from that, I'm going to get a z value. So how do I find that? Well, now that I know where I am in my table, I'm going to now work out to find where that z-score is. So here my row is the negative 1.2 row, and my column is the 0.08. So if I put those values together, I'm going to get a z of negative 1.28. Let's do that process again. So we're looking for 0.1000 on the inside of our table. I look down this first column to look for my jump, where 0.100 happens somewhere between them. And I go over sort of in both rows till I find the closest thing I got, which is this 0.1003. But that's still not a z-score. I have to work out to figure out what row and what column I am in to get my z-score. So that's how we get that negative 1.28, which is negative just like we expected it to be, so that I would be below the mean. Or now intuitively thinking about this number, if I want the bottom 10% of women's heights, I got to go below the mean by 1.28 standard deviations. So now I'm going to take this formula we have here, and now I know everything to plug in. My z is going to be the negative 1.28 that I just found. My standard deviation is that 2.75 given to us earlier, and the mean is going to be 65. And when I do my math here, I get 61.48. Now remember, what we just found here is a woman's height. So this is in inches. So this is about 5'1.5", which at least seems to be a reasonable height for a woman. At this point, the math is done, and all we need to do is interpret this value. So what this means for us is that 10% of women are shorter, because it's shaded left, shorter than 61.48 inches tall. So as you can see from this formula, since we're going to know the standard deviation and the main work here for us is going to be finding the z. So we're going to do some more of these in the next couple of videos.